Imagine standing on the deck of a small ship in the Mediterranean Sea more than 100 years ago. Beneath the waves lies a shipwreck that has been hidden for nearly 2,000 years. Divers descend into the dark water expecting to find statues, coins, and pottery. Instead, they recover a strange lump of greenish bronze covered in centuries of hardened corrosion. At first, it looks like nothing more than a broken piece of metal. No one realizes they are holding one of the most extraordinary archaeological discoveries ever made. For decades, this mysterious object sits quietly in a museum. Visitors walk past it without giving it much attention. Archaeologists focus on the beautiful marble statues recovered from the same shipwreck. The strange bronze fragments seem insignificant. But sometimes, history hides its greatest secrets inside the objects that appear the least remarkable. As scientists begin taking a closer look, something unexpected appears beneath the layers of corrosion. Tiny bronze gears. Not one or two, but dozens of precisely crafted gears fitted together with astonishing accuracy. This is impossible, or at least that is what many experts first believed. According to everything historians thought they knew, machines this complex simply did not exist in the ancient world. For generations, people believed that sophisticated gear-driven mechanisms were inventions of the medieval period. The accepted timeline suggested that technology of this complexity would not appear until more than 1,000 years after the fall of the ancient Greek world. Yet here was a heavily corroded object recovered from an ancient shipwreck, apparently challenging that entire assumption. The story begins in the spring of 1900, when a group of Greek sponge divers sought shelter from a storm near the small island of Antikythera, located between mainland Greece and Crete. While waiting for the weather to improve, one of the divers descended into the clear waters below. What he found was unlike anything anyone had expected. Scattered across the seafloor lay the remains of a massive ancient ship. Marble statues rested silently beneath the water. Bronze sculptures, glassware, jewelry, pottery, furniture, and countless other treasures surrounded the wreck. It quickly became clear that this was one of the richest archaeological discoveries ever made beneath the sea. Over the following months, Greek divers carried out an extraordinarily difficult recovery operation. Working with the heavy diving equipment available at the time was extremely dangerous. The pressure, limited air supply, and lack of modern safety procedures placed their lives at constant risk. Several divers suffered serious injuries, and one tragically lost his life during the operation. Their efforts, however, brought hundreds of ancient artifacts to the surface, preserving a remarkable piece of history for future generations. Among those recovered objects was the small corroded lump of bronze that almost no one noticed. It was transported to the National Archaeological Museum in Athens, together with the rest of the artifacts. At the time, nobody imagined that this broken object would eventually become more famous than many of the magnificent statues recovered from the same shipwreck. The ship itself is believed to have sunk sometime around the 1st century BC, while carrying valuable cargo across the Mediterranean. Archaeologists think it was transporting luxury goods that included bronze and marble sculptures, glass vessels, jewelry, coins, and other expensive items, most likely destined for wealthy buyers in the Roman world. Although researchers continue to study the wreck, many details about the ship, its crew, and its final voyage remain uncertain. Then something happened that changed everything. As the bronze fragments slowly dried after centuries beneath the sea, they began to crack apart. Hidden inside the corrosion were carefully cut gear teeth unlike anything archaeologists had ever seen from the ancient world. These were not random pieces of metal. They were components of a sophisticated mechanical device, built with extraordinary precision. At first, few people understood the significance of the discovery. The fragments were incomplete, damaged, and incredibly difficult to interpret. Some scholars wondered whether the gears belonged to different objects. Others questioned whether such an advanced mechanism could truly be ancient. The discovery seemed almost too remarkable to believe. Over the decades, new generations of researchers returned to the mysterious fragments again and again. Each advance in science allowed them to see something previous generations could not. As technology improved, the hidden secrets locked inside the corroded bronze slowly began to emerge, revealing a machine unlike anything ever found from the ancient world. But the greatest surprise was still waiting, when scientists finally understood what this mysterious device was actually designed to do. It forced historians to rethink what ancient engineers were capable of achieving nearly 2,000 years ago. For years, the mysterious fragments remained one of archaeology's greatest puzzles. They were too badly damaged to understand with the technology available in the early 20th century. Scientists could see the gears, but they had no clear picture of how the pieces originally fit together or what the machine was designed to accomplish. One of the first researchers to seriously investigate the mechanism was the British historian of science Derek J. de Solla Price. After studying the fragments for many years, he published groundbreaking research that transformed the way scholars viewed the discovery. Price argued that the device was not a simple collection of gears. Instead, it was an incredibly sophisticated mechanical instrument built to calculate astronomical events. At the time, this conclusion seemed almost unbelievable. If Price was correct, it meant that ancient Greek engineers had created a machine far more advanced than historians had ever imagined. As decades passed, researchers continued examining every surviving fragment. Today, 82 known pieces of the mechanism remain. Some are no larger than a coin, while others preserve sections of bronze plates, gear wheels, and faint inscriptions. Although much of the original device has been lost to time, these surviving fragments contain an extraordinary amount of information. The front and back of the mechanism were once protected by bronze plates covered with detailed Greek inscriptions. These were not decorative markings. They served as instructions, almost like a user's manual, explaining how different parts of the instrument functioned. Even after nearly 2,000 years beneath the sea, modern imaging techniques have allowed researchers to read many of these tiny inscriptions, revealing valuable clues about the machine's purpose. As scientists carefully reconstructed the surviving gears, an astonishing picture began to emerge. The mechanism was built using dozens of precisely cut bronze gears that transferred motion through carefully calculated gear ratios. Turning a single handle would cause multiple gears to rotate together, each moving at a different speed according to mathematical relationships designed by its creator. This level of craftsmanship required remarkable skill. Every gear had to mesh accurately with the next. Even small errors would have prevented the machine from working correctly. The precision seen in the surviving fragments demonstrates an advanced understanding of mechanics, geometry, and metalworking. But perhaps the most surprising discovery was not the gears themselves. It was what those gears were actually calculating. Researchers found evidence that the mechanism tracked the movements of the sun and the moon across the sky. It could also model the changing phases of the moon, using an ingenious arrangement of gears that reproduced the moon's slightly irregular motion around Earth. This feature was particularly impressive because it reflected astronomical knowledge developed by ancient Greek scholars through careful observation and mathematics. Further study revealed that the mechanism also included calendars. One dial represented a 365-day Egyptian-style calendar that was widely used for astronomical purposes in the ancient Mediterranean. Another tracked a longer cycle known as the Metonic cycle, a period of 19 years during which the phases of the moon repeat on nearly the same calendar dates. Ancient astronomers used this cycle to coordinate lunar months with the solar year. These discoveries suggested that the mechanism was much more than a clock or a calendar. It was a compact astronomical calculator capable of modeling several different cycles at the same time. By simply turning a handle, its user could predict the positions of celestial bodies and important calendar events with remarkable sophistication. As exciting as these findings were, many questions still remained unanswered. Scientists could identify several gears and understand many of their functions, but significant portions of the mechanism were missing forever. reconstructing the original machine would require new technology far beyond anything available to earlier generations of researchers. That breakthrough finally arrived at the beginning of the 21st century, when an international team decided to investigate the fragments using imaging methods that had never before been applied to an ancient artifact. What those scans revealed would completely change our understanding of this extraordinary machine. When the new investigation began, researchers realized they were looking at far more than a collection of damaged bronze fragments. Advances in imaging technology gave them an opportunity that earlier generations of scientists had never had. Instead of trying to guess what lay hidden inside the corroded metal, they could finally look beneath the surface without damaging the artifact itself. The work was led by the Antikythera Mechanism research project, an international collaboration of archaeologists, astronomers, engineers, historians, and imaging specialists. Among its leading members were Professor Mike Edmonds of Cardiff University, mathematician and science writer Tony Freeth, astronomer Xenophon Mousas, and several other experts who combined their knowledge to solve one of archaeology's oldest puzzles. Using powerful three-dimensional X-ray computed tomography, together with high-resolution surface imaging, the team examined every surviving fragment in extraordinary detail. For the first time, scientists could see gears hidden deep inside the corrosion and read inscriptions that had remained invisible for nearly 2,000 years. The scans revealed an astonishing level of engineering. The mechanism originally contained at least 30 interlocking bronze gears, although some researchers believe there may have been even more. Every gear had been carefully cut by hand, with teeth designed to mesh precisely with neighboring gears. This was not the work of an amateur craftsman. It reflected exceptional technical skill and careful mathematical planning. One of the most remarkable discoveries involved the moon. Anyone who watches the night sky over many months will notice that the moon does not move at exactly the same speed throughout its orbit. Ancient Greek astronomers had recognized this long before modern telescopes existed. The Antikythera Mechanism included an ingenious gear arrangement that reproduced this changing motion mechanically. By turning a simple handle, the user could watch a pointer represent the moon's changing position with impressive accuracy for its time. Researchers also confirmed that the mechanism could predict solar and lunar eclipses. On the back of the device was a spiral dial representing the Saros cycle, a period of approximately 18 years after which similar eclipses repeat. Ancient astronomers had known about this cycle through centuries of careful observation, and the mechanism translated that knowledge into a portable mechanical calculator. Another spiral dial represented the Metonic cycle, allowing users to coordinate lunar months with the solar year. Additional inscriptions suggest the mechanism also tracked the timing of important Greek athletic festivals, including the Olympic Games and other major competitions that brought people together from across the Greek world. This showed that the device was useful not only for astronomy, but also for organizing events connected to Greek society and culture. As more inscriptions were decoded, researchers gained a clearer picture of how the mechanism was intended to be used. Rather than simply displaying information, it acted as a predictive instrument. By rotating a hand-operated crank, the user could move both backward and forward through time, seeing how astronomical cycles changed from one date to another. In many ways, it functioned like a mechanical model of the heavens. The discovery transformed historians' understanding of ancient engineering. Before the Antikythera mechanism was studied in such detail, many scholars believed that mechanical devices of this sophistication did not appear until medieval Europe, more than 1,000 years later. The mechanism demonstrated that highly advanced gear technology already existed in the Hellenistic Greek world during the 1st century BC. Even so, responsible historians are careful about how they describe this achievement. They do not claim that the Antikythera mechanism was identical to a modern computer. Instead, they describe it as the oldest known analog computer, because it used mechanical components to model and calculate real-world astronomical cycles. It solved a specific class of problems using gears rather than electronic circuits, making it fundamentally different from today's digital computers while still representing an extraordinary computing device for its era. The more scientists learned, the more fascinating the story became. This was no isolated curiosity built by chance. It reflected generations of accumulated mathematical knowledge, astronomical observation, and remarkable craftsmanship. Yet one question continued to puzzle researchers. If engineers could build a machine this sophisticated over 2,000 years ago, why do we find so few comparable devices from the centuries that followed? That mystery would lead historians to explore one of the most intriguing chapters in the history of ancient technology.